All right, today we're going to embark on flashing this up with BetaFlight 25.12, not 4.6. What you would know is BetaFlight 4.6 if you follow stuff, but it's actually going to be version 25.12 once it's released here this next coming month. So this is an old wing I have, the Micro Sky Hunter. I used to use this for a little long range, like back in 2017. But with that setup, it was loaded up way too much with too much weight. So we're going to strip it down, and I'm going to flash over BetaFlight to this. And I think it will be a good little craft for something like BetaFlight because it's a fast little dart. And I think that's really what you'd be looking for, why would you use BetaFlight on something? I wouldn't necessarily use BetaFlight or be interested in flashing BetaFlight to a wing that I want to use for long distance. I think iNav's the best candidate for that by far because it has return to home and all kinds of stuff. But if it's something fast and agile, BetaFlight has a lot to offer in this new release with how it adjusts TPA and PID. And if you have something like this with an engine and you're looking to put a flight controller on it, BetaFlight has a lot to offer for something like this as well, where this is going to put off a lot of vibration. By and large, BetaFlight has the best filtering, but the dynamic notch that you would use on something like this, because this puts off a lot of vibration. So that would be the two use cases for BetaFlight, but enough gabbing. Let's get into how to flash BetaFlight to that Micro Sky Hunter and start this series and going through the different steps to get it set up and flying.
I'm always amazed when I look at this statistic that only about 45% of you that are watching this are subscribed to this channel. So if you're enjoying this content, please hit the subscribe button down below so you don't miss any future content in this series.
So for this project, I'm going to be using my Omnibus F4 SD card. And the reason being, I'll show you here why in a second on a pinout. So you're going to want to take into consideration some things. Another good thing about BetaFlight is all the flight controllers have targets in BetaFlight. So you can really use anything. I have here also a CL Racing F7, a CL Racing, this is V1, V2, just any flight controller you have. But that said, I'm picking this Omnibus F7 because of the way the PWMs or motor outputs are arranged on here. You can actually put in some nice pin headers here, which make things a little easier. So I would be selective and personally look for something like that. And let's talk about why that might be important. So if you look on this graphic right here, you can see how the pin headers or the motor outputs for PWM 1, 2, 3, and 4, which you see the same here for an ESC socket, have its own nice headers right here. In addition to that, it has a ground on this side, and then the center is going to be your positive. So this is your 5-volt positive here. So this is your positive rail, your ground rail, and then your PWM outputs. Well, that is perfect for pin headers, as you can see that I have on there, right? Those little pin headers put on there. And what's also great about that is that when I go ahead and plug in, I need to power this. I'm going to end up powering it with the BEC on the wing here. The ESC is going to have a BEC that puts out 5 volts, and that BEC is going to be rated typically on a wing or a plug and play to operate the servos that come with it. Otherwise, if you're going to put all your main power through here and rely on the BEC that comes on the flight controller, you've got to be cautious about how big that BEC is and how big your servos are and how much power they draw. Whereas if you're powering it from the ESC that came with maybe the plug and play wing or any kind of wing ESC, it will have enough amperage to power those ESCs. Since I'm going to be plugging the motor into PWM1, the BEC is going to feed 5-volt power back into this pin right here. That is on the same circuit as this pin, and this pin. So essentially it's going to power my flight controller, the whole thing, and the power draw for these pins, which are going to operate the servos, will come directly from this pin, which is being powered by the BEC. So it puts it all in line. Now, again, you can do that with any flight control and any BEC. You could just wire the 5 volts that come from the ESC to your 5-volt rail on your flight controller and have the same thing. That 5-volt circuit that's on your flight controller is all one wire or all one slice of the board. But the big thing for me on this is just ease of, putting it together. I'm just going to plug the servos into these pin headers here. I'm not going to have to wire them and solder them to ground, solder them to 5 volts, solder them to the signal wire, do the same for the next servo, so on and so forth. I just plug them right in. Same thing for the BEC. I'm just going to plug the BEC into the flight controller. So something that allows for a pin header is going to be a lot easier. But that said, with BetaFlight, you can really use any flight controller, and all the targets are there. Whereas iNav, it's probably, I would say there's like a quarter of the there's a lot of targets in BetaFlight compared to any other firmware out there. So sky's the limit on what flight controller you want to use. Now, to flash this up, we're going to go to the firmware update. First, if you're not familiar at all, we go to apps.betaflight.com in your Windows Chrome browser. So you go to apps.betaflight.com. That will take you to this website. You can hit the little button up there in the browser in the address window and then just download it and have a local install of it, like a cached install. Nevertheless, using the BetaFlight app, we're going to go ahead and detect the board. Now I'm going to use a dummy board here just to show you guys this flashing. But if it has BetaFlight on it, you should be able to just hit auto detect. If it doesn't have BetaFlight on it or it's really, really old, then you might have to select the flight controller that you have there. We are going to put in the 2025 12.0 RC2 release. That's going to be in stable release here coming up in December. That's essentially BetaFlight 4.6, got renamed to 2025.12. And so it's after that video, you would be in stable release. If you're not seeing that there, you'd hit expert mode or just click show release candidates, and then you can see it down here. The thing that we're going to want to make sure over here is that we have wing selected as an option. The other thing I would do, I'm pretty sure it comes along for the ride. I'm like 99% sure it comes along for the ride, but I would probably recommend clicking on servos as well. Just a little belt and suspenders there. As of this release, the 2025-12, there is no altitude hold or position hold with a wing with BetaFlight yet, so no need to click on those. There's other options in here if you're, want GPS just to report your position or other things, or LED strips, so on and so forth. For a wing, you're never going to need magnetometer. It's not going to use it anyways, so even if you are doing GPS, you don't need magnetometer. You will need the pin IO, definitely keep that in there. And then you can, race mode has like some CAC modes and other kind of racers things. So if you're going to be racing the wing around, you can click on that as well. Those are the essentials. Going up to the top here, make sure you're selecting either you have a digital or analog VTX. In this case, I'm going to have an analog VTX for this sucker. And the other thing you're going to want to pay attention to that you may never have paid attention to before is your motor output. On most plug-and-play wings, the ESC is not going to support some of these higher protocols. This is an eSheen wing from 2017. It only supports PWM output to it. It's made just to have a receiver in it, and that's it. So mileage may vary. If you have a more modern ESC, it might support D-shot. Some kind of middle of the roads might support multi-shot, one-shot. Just be cognizant of that. You have to pick only one of these, unfortunately. That if you just pick D-shot and then you can never get your motors to work, it's because they don't support D-shot. So pay attention to that. I think every ESC, if I'm not mistaken, supports PWM. That's like the foundation of what ESCs were created on back prior to 2015, and even somewhat in the 2017. I guess not so much in the 2017 era, but nevertheless, just pay attention to that. If you want a safety net, I would probably select PWM to start, and then you can change that later or reflash it. From there, we should be in good shape. So I got my servos, got my wings, I got my PWM. I'm gonna hit load firmware online, let that build, and then once that builds, I can hit flash firmware and it will flash it up. So she's all built. Now I can hit flash, and then it's gonna go ahead and reboot into bootloader mode and flash that. If you have an issue where it goes boot on your computer and then it doesn't boot in, like getting into bootloader mode, if you have a receiver wired to it and it's active, some flight controllers, when a receiver is wired in, like the one, that Omnibus F7 SD, if my receiver is wired into this and it's powering the receiver, it won't go into DFU mode. This one you can see it was just fine. But this one it won't go, so I have to unsolder the 5-volt wire, flash it, resolder. That's why I'm not using this right now. I'm using the dummy one because I'm not doing that again. But just be cognizant of that. If you're having issues with flashing, it's not going to DFU mode. Unsolder or disconnect your receiver. Some flight controllers have the issue, most don't, but some do. So I'm gonna switch now over to this Omnibus flight controller I have, and I reset this. So I'm gonna start from scratch on it. And we're gonna go through and get this set up. This is not gonna be the full setup of it, but I wanna at least get you moving to the spot where your servos move. And then we're gonna go from there to get the rest of it set up. We're gonna talk about some PID tuning parameters, S-term versus the PIDs and how they relate to each other, and just a bunch of stuff that is very similar to iNav, but just a little nuance different in BetaFlight. But in this one, I want to get you set up at least to get the dang servos moving and the motor working, and then we'll have the next video for the rest of it. So anyways, switching over, clicking on my Omnibus SD or Omnibus F4 SD card, and then clicking onto here, you can see I have it, it's working, so good test there. You can always go down here and look in the config to see what parameters you had added to this. If you forget, like if you didn't select wing or something of that nature, or if like did you have PWM or D-shot, things of that nature, you can click on that down here, or in the options down here as well. So in here, what I recommend, the first thing you do is try to get your receiver working. So have a receiver. I'm not going to go through getting receivers set up. I have an Express LRS one on here. It's all bound to my radio. It's wired up correctly. This is not a video on how to do that, but I need to enable my RX serial 1. That's where I have my receiver. We'll go ahead and let that cycle. Click back into that. We're going to do our standard calibration. Put it on the desk flat-ish and hit calibrate accelerometer. There we go. Then that that message stops coming up. We're going to go into our receivers tab, move around our sticks. Yes, okay, that's working great. From here, we need to go down to the motors tab. So standard stuff, the mixer that a quadcopter uses is not what we're using. If you're doing a flying wing, you'd want to select this. If you're doing more of an airplane setup, something like this is typically what I'm using on an airplane. So we're going to select that there. We're going to hit save and reboot because I have more conventional wing. I don't have a rudder, but that's fine. We just won't use that part of it. This said, you should know BetaFlight's not as polished as iNav when it comes to this stuff. So it's a little rough. What we want to do now is, now that we have that set, I'm going to go ahead and get this all plugged in, and what you will find out when you plug yours in to the everything, that your ESCs or your servos aren't going to work. Your ESC should work now, so we're going to put that on motor 1, and then when I move the motor slider up, we'll show that in a second, that will work, but the servos won't work. So we're going to have to do some remapping, unfortunately, to make those work. So let's step through that process and what we have to do there. Okay, so as discussed, I have these pins all connected. This wire here is coming from the ESC. This is the BEC. This is actually going to power the flight controller. This is going to be the signal. This light, I don't know, brown wire is the signal wire from the flight controller back to tell the motor to spin. But the red wire, or is it red? Yeah, red and dark brown, weird convention, are the power and ground coming from the BEC towards the flight controller to power that and all the servos on that same rail. Then I have my ailerons plugged in, so that's in motor 1 or PWM1, the motor 1 output on the flight controller. They call it PWM1 as well here on this Omnibus F4 SD card. Then I have in PWM2 or motor output 2, got nothing. And then in 3, I have the ailerons, and in 4, I have the elevator. So elevator, ailerons, nothing, and then the BEC, the motor output for the motor in the back. The other thing you're gonna need obviously here too is a battery, just to, check that your motor's working. and have your ESCs or your servos move, you need a battery to power that. So with this mixer set, the first thing we can do is check does our motor work now? So I'm going to go ahead and plug it in, and you should hear it. Dun, 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 dun. You know, it should give a power up like the ESC will normally do. I'm not sure if you heard that because I have no noise canceling software. And the other thing we can do is just in then BetaFlight, just go into the motors tab like we normally do, and then just move up the motor, and you should see it move. You might be able to hear it, but you can definitely see it there if you're looking right there. When I move this up, it's moving it. Obviously, if it's, you know, reminder, if it's a new wing back in before PWM and D-Shot days, that if you, let's turn this off. If you if it's not a D-Shot ESC and you have not calibrated ESC, just remember you have to do that. So let's talk about that little reminder from blast from the past. What you need to do there is take the input all the way up with the battery unplugged, plug in your battery, and then your ESC will beep weird. It will go, just went dint, 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 and now I can move it all the way down. And then let it go, and it will calibrate the endpoints for the ESC from 2000 or whatever you have input, 2000 to 1000. Don't forget about that. We don't need to do that anymore with D-Shot, but if you're using PWM and it's a brand new ESC, you may need to do that. Okay, so that is working great, but I still have it all plugged in here, as you can see. But when I move my sticks, unfortunately, my servos don't work. You can see it's moving on BetaFlight. My little plane's moving, but my servos don't work. Well, why aren't they working? Well, from here we need to go in to the CLI and type in resource. And we need to look here, and you can see a telltale sign is none of these resources say servo. Well, that's a problem. They need to say no servo outputs. So this is each output. Motor 1 output, go to this pin. That's a physical pin on the flight controller. Motor 2, go to this output. Motor 3, go to that, so on and so forth. All these different outputs, all these different pins on the flight controller, physical pins. And these are what the flight controller knows as resources within the computation, within the computing of the flight controller itself. So it's not directing any servo outputs. We can go to servos here as well. And if we look under there, we can see now that when I move my ailerons, or when I move my roll stick, I have servos 5 and 6, or 4 and 5 going. And then when I remove my elevator, I have 7 going up and down. So you can see that. And then yaw is 6 here. So just because, programming sucks and how this all works, and programming you start with 0 because 0 is a number. There's some back and forth here. So what we need to do here now is go back into the resource tab, and we need to look at that again and type in resource, spell it correctly. And then we need to set some resources. Like I said, we're using motor pin 3 and 4. So it's really the A03 and A02 are the pins we're actually using. That's what we really care about, A03 and A02. I don't really care that it's motor 3 and 4. We're just using that because we know that's PWM 3 and 4, or motor output 3 and 4 on all the diagrams. And these are the actual pin numbers that it corresponds to on this specific design for this specific flight controller. So going back and using this diagram as a reference, what we're going to do is set servo 5 in the resources to what we have, to the pin that we have the elevator plugged into. And we're going to set servo 2 to the pin that we have the ailerons plugged into. So we're going to go into the CLI. We're going to type resource, and then we will type, and we can see them up here, which is perfect. So we're going to say resource servo 2, just 2, and we're going to have that go to, so that's SERVO 2. We're going to have that go to A03. Then we're going to type in resource servo 5, and we're gonna have that go to this pin, A02, right? So we're putting servo 2, which is our ailerons, they're going out to this pin, and our elevator's going out to this one. That's correct. Type in, hit save, and after you do that, you should start to see your stuff move. And you can see I have the rudders here, or the elevator here moving as well when I'm moving that, and I got my ailerons moving here as well. When you clicked on this video, did you notice there was no ads and there's no mid-roll ads? Well, that's in thanks to my Patreons. If you're enjoying this content, please check out the link below to my Patreon. I provide bonus content for my patrons only for a deeper understanding of the topics I'm covering. Specifically for this topic, I'm going to provide a bonus content video on the S-Mixer in BetaFlight to have a deeper understanding of mixing, servo mixing, motor mixing, and how that all works together for a custom mix design, so you're not just limited to those presets that you have as for airplane, flying wing, so on and so forth. Again, if you're interested in that, check out the links below. Okay, and don't forget, we still have to, now that that's working great, we have to do some cleanup here yet. So go back into the CLI, type in resource, and then in here, this motor 3 and 4, we don't want to have servos and motor outputs going to the same pin. So we're going to type in resource motor 3 none, resource motor 4 none, and then type save there as well. Okie doke. So yeah, everything should work now, right? See that? You got some, servos working. You got your motors working. There's some other things you can do by going into just the servo output here. And it's a little weird because, just the servo numbering. So like this is servo, this 4 is actually 2. So 2 of these here, I guess, are motor 1, motor 2. So this is servo 1, 2, 3, 4, 5. Since this is motor 1, motor 2, as in that diagram, that airplane diagram. Then again, servo 1, 2, 3, 4, 5. So it's just, the numbering between the stuff is difficult to follow. But hopefully now you have a better understanding because, somebody's telling you, and it's not like you just have to go try to figure this out on your own. With that, you might have some things that you want to switch around here. You can put this into live mode here, and then you can go ahead and change these rates. You can flip stuff. So if I wanted to have the servos go backwards, so I could set this here to, let's see, let me turn this off as well. So I wanted this to go in reverse. I could say, and let's actually turn that image back on. So if I had these full this way, and I would go up to, I don't know, I guess it's servo 2 now. If I go and switch that to this, if I have to hit save, does that then flip that? No, it didn't. So which one is it? It's gonna be, maybe it would be 4. So go to 4 and say, I'm gonna flip that. There you go. So here it's 4, but in the resource, it's servo 2. So you're never gonna have to go back to the resource mapping. So here you can just, whatever you see here for the numbering is up here. Just know that 4 was actually 2 because this is again servo 1, 2, 3, 4, 5 as it relates to resource mapping. Anyways, not very easy to understand, but again, at least I'm here telling you, and from there you can go from there.
I wanted to add a couple things here. As you can see, as I move my roll stick, both servo 5 move together. To change that behavior, all you need to do is go under servo 4 or 5, it doesn't really matter. And then you can go down here and change it to a negative. So if I do that, now you can see they go 2 separate directions. And the reason you're seeing that live update on screen is if you enable this live mode and hit save, then whatever changes you do here, it's happening right away. So that's nice when you have the battery plugged in, you can kind of tweak things around in here. And as you're making these changes in these percentages for how much throw you want, if you want one throw to be less than another, like you don't need to be 100%, this could be 85 and this could be 100, so on and so forth. Then you would see that live happen. You could see your plane and your servos move and update. That's what this live mode is. To enable this, you have to enable it and hit save and then start doing your stuff. And then once you're done making your tweaks, then I would hit save again here. One of the primary differences between, say, airplane mode and flying wing, if you would set flying wing, when I do my roll, you would see the same behavior here. But then when I do my elevator or my pitch stick, instead of moving servo 7, you would see both of these go up together. So you'd see them differential, but then both go up together. And that's obviously, that's what a flying wing does. You have the ailerons that are separate, but then when they both need to go up together, they both go up together. Then they, by default, you wouldn't have to reverse this 100%. They would work like that, I believe, automatically. I haven't double checked that. You'd have to verify that for me if you have a flying wing.
I'm going to have more videos on taking the rest of the way because there's more. There's S terms, there's PID gains, and there's a whole wiki that I'll drop a link down below that helps you with setting this stuff up. It gets a little easier from here, but there is some stuff you need to know. We're going to go over between PID gains and their overall magnitude, and then the S term and how you can essentially tune that between those two on the bench, and I'll show you some ins and outs with that. So if you're interested in that, please make sure you're subscribed. That video will be coming up next. Thanks, everybody. Hope this helped. If you have any questions, comments, or troubles, don't hesitate to put those down below as well. Thanks, everybody. See you in the next one.